So what I'm going to talk about today is something I actually have never spoken about. So I recently had a realization, and it uh, which is that helping is the really the only model that we have of an intrinsically rewarding behavior. Now that doesn't mean anything to you quite yet, but I'm going to tell you what that means and why this is super important and valuable. Okay, so you all have heard about reward. There are reward circuits in the brain, and these are organized around uh, something that we evolutionarily need to do, which is to uh, pursue primary rewards. And the primary rewards are food, water, and sex. These are the things that will keep us alive and keep the species going. And so evolution has made these things that these three goals, things that we animals crave. We don't say, "Oh, gee, I had food today. I don't need any more food," or "I had water," or there's a my mate and we're not going to have sex. So the primary rewards are all things that are of absolute advantage and are things that motivate behavior. You may so there's a critical difference between the reason I put reward into parentheses is because I really dislike the word. We don't sit around and think, oh, gee, how happy am I? How fabulous is this? In fact, we don't stay happy for very long. But what we do is we stay in a state of desire, a state of craving. And if you think about evolution wants you to be in a state of craving. It doesn't want you sitting in nirvana on a couch and doing nothing. That is death. That is evolutionary death. So craving is the thing that the brain really codes for. It's not, oh, that's fabulous. It's, oh, I want more of that. So the primary rewards are food, water, and sex. There are secondary rewards such as money, which are valued because they're associated with the primary rewards. There are also, in modern day, we have other rewards such as cocaine or heroin or alcohol, caffeine, all of which are rewards, and they're in a different category. They hijack these circuits to produce a pharmacological shortcut into the primary reward circuits. So in contrast to primary rewards, there are intrinsic rewards, and intrinsic rewards present no immediate survival benefit. It's not going to make you live longer, or it's not going to immediately increase the fitness of the group. And in humans, there are quite a few of these things. We know that people get the reward circuitry, this circuitry that is, say, activated by cocaine, that same area called nucleus accumbens is also activated when people donate. And I would argue that the rats, when they help, are doing it for an intrinsic reward. And they want to do it again because they liked that intrinsic reward. So that's what I'm going to try and convince you of today. Okay, so this started with trying to not look at intrinsic reward, but trying to start looking at empathy and helping. So the idea was we knew that one rat could contage or catch the affect of another rat. And the place where this has been studied the best is that if one rat is scared, because let's say it's been put into an environment and shocked, and now when it gets into that environment, even without any shock, it's going to freeze, and it will physiologically express markers of being afraid. And another rat who's never been shocked will look at that rat and start to exhibit the same fearful behavior. So that's a situation where that fear affect has been communicated from one individual to another individual, and that is a very rudimentary form of empathy. So we knew that back, when you were children, okay, so 15 years ago or something, we knew that rats could catch an affect from another rat. But what my graduate student at the time, Inbal Benami Bartal, wanted to know is whether the rats could do anything. Could they use that caught distress to motivate them to do something? And what Inbal wanted to test was whether it would motivate them to help the individual in distress. And so to do this, we basically had to set up a paradigm where the rat could help. And that was not the easiest thing in the world. What we ended up coming up with is about a foot cubed arena. And in the middle of it, we put this restrainer, which is pictured here. And there's a rat that's trapped in there, and then there's a free rat. But this door, which is the only door to the restrainer, can only be opened by the outside. So it can only be opened by this rat. It can't be opened by this rat. And we said, you could go sit in the corner, ignore the trapped rat, or you could do any number of things. Well, as it turns out, what they do is they open the door. They open the door, the trapped rat gets out. The next day they come back and they open the door much faster, because now they figured out how to do it. Now they start doing it. And we test them for 12 days. By the 12th day, they'll go in, they might look around, make sure that it's the same thing as yesterday, and then they'll open it right away within a minute or two. So that's the paradigm. And now I'm going to just show you what this looks like. So in the first in the first minute or so, you're going to see a sped up version of a rat on the first day that he's exposed to a trapped rat. So it's sped up by 20. He's just been put in. Oh, why did that happen? Let's try that again. Okay, so I'm not going to touch it. So he's just been put in. And what you can see is that he goes into the center of the arena, and that was telling. We sort of knew that this was going to work just from that, because rats like to stay at the edges of arenas. When they go into the center, into the open spaces, that's where the hawks get them. Now, this is the first opening. And what you'll see is it's at minute 25. These rats have been in there for 25 minutes. This is a very hard thing to do, to figure out how to open the door, but eventually he gets it. And what you're going to see is not a glitch in the video. The door is going to fall over. It's going to make a sound. And did you see that both of the rats froze? They froze because they were surprised by the sound that the door made. So that's on day 5, minute 25. We also see this following behavior where the free rat follows the trapped rat. The free rat is in general way more excited by what he's done than the trapped rat is. And finally, on the last day, this is day 12, you see the rat going in for the first time. And now he runs around, he makes sure it's the same gig as yesterday. And then he's going to go over and he's going to open the door right away. Right there. And what you see is that they don't freeze. So now that sound, the door still made a sound, but that sound is completely anticipated. So they're making an intentional action. They know exactly what's going to happen as a result of their action, and they make it anyway. Okay. So this is a format that I'm going to show you a bunch of times. So each row is a different rat. Each column is a different day. So they're destined for 12 days. And what I've done is I've color coded it so that if they open once in a row, it's yellow. And if they open 12 times in a row, it's red. And 11 times is close enough to 12 that it still becomes red. And so what you can see here, these are 24 rats. And basically a bunch of them, they open on the second day, and then they almost invariably, with one exception, they open on the third day. Once they've opened twice, they always open for the rest of the time. So essentially, this is a conversion. They've converted from not opening to opening. So what's the hurdle? The one hurdle is that they have to figure out how to open the door, which is not trivial. They on average learn how to do it around day 3 or 4. So they're not humans, they're rats, and this is a tough task for the rats. But once they open it again. And what does that tell you? That they open it the next day. Well, it tells you that they had a good time. When they opened it on the first day, that was a sufficiently good experience that they crave, they desire to do it again, to achieve that same experience again. So they open again. And not shown here, but I'll show you in a minute, is that with every passing day, the time it takes, the latency it takes before, from the moment that they enter the arena to the moment that they open, keeps on decreasing. And it asymptotes to basically 0. Less than a minute. Okay. So how big a deal is it that rats open a restrainer door? And so to ask that question, we're going to say, what's the floor and what's the ceiling? So the floor, it would be that there's no rat involved. So there's an empty restrainer. Are you going to open? Do you open the restrainer essentially because it's Mount Everest, because it's there? You get your kicks by opening a restrainer? That's a possibility. So to test that, we put in an empty restrainer and we say, will you open for an empty restrainer? And then what's the ceiling? The ceiling is, will you open for the self? And to do that, well, all we do is we turn the door around. So now the rat is trapped and can get himself out. Or he could stay there and sit, up to the rat. And so here's what happens. So now there's a different format. On the left is the latency. So you see they're tested for 40 minutes and tested for 12 days. So this is the testing day from day 1 to day 12. And this is the latency, the median latency. And when they're tested with an empty restrainer, the median latency is 40 minutes because they, in fact, in this group of 8 animals, there was only one opening on day 12, which is over here where we have the percent of rats that opened. So if they're given an empty restrainer, they're not going to open. The rats will only open for another rat. How much, maybe they like it in the restrainer. Maybe it causes them no distress. Maybe they prefer to be in the restrainer. Well, that does not appear to be the case, because when we turn around the door, most of them actually open on day 1, and by day 3, they're all opening except for one guy who was chill on the whole thing. So what that tells you is that they don't want to be in the restrainer. It also tells you this one rat that didn't self-release. He did self-release once or twice, but he didn't consistently self-release. Tells you that the distress of the situation is not so supreme that they're escaping at all costs. So they don't want to be there, but there's no pain involved. There's no real suffering, except they'd rather not be there. Okay, so this is the space of the paradigm. This is between no helping and pretty much complete helping. Let me mention one more thing, which is that with this empty restrainer, because this one rat opened on day 12, we wanted to test whether that opening was actually something that the animal developed a craving for. So we tested all the animals on day 13, and neither the rat that opened on day 12 nor any of the other rats opened. So that's 8 rats times 13 days, which is 104. So in 104 tries, there was one opening, which means they don't open for an empty restrainer. Okay, so where does testing with a trapped rat sit in this? And that's shown in this red. So here is the median latency of a group of 24 just control rats. And this is the proportion that help. And so what you see from the latency graph is that they convert from being non-openers to being openers. And there's no difference between how they open for the self or how they would open for another trapped rat, a different rat that's trapped. So they are treating that other rat as though it was the self. This is an ancillary point that we can come back to, but about 25% of the rats don't open ever for a trapped rat. And I'll give you the quick version of that, which is that they could be opening because they don't care. They're psychopathic rats. They just don't care about the plight of the trapped rat. Or they could be not opening because they care too much. And it is the latter. They care too much. So they have the highest release of stress hormone. The ones that don't open have a much higher release of stress hormone than the ones that do open. Okay. So coming back to this, what this tells you is that opening for a rat is highly, highly reinforcing. Another way, one of the things that we did once we saw this is on day 13, this was a pilot experiment, we would give the rats an empty restrainer, and lo and behold, they would always open for the empty restrainer. Now recall that if they're first tested with an empty restrainer, that is not enough for them to start opening. But if they've already been opening for a rat, they will then open for an empty restrainer. And what that means is that helping or door opening has become what we call a habit. And a habit is something that is outcome independent. So an example of that is a person takes a drug of addiction, such as, let's say, cocaine or heroin. And on the first day that they take it, it feels wonderful. So the second day they take it and it still feels pretty good. But by the time they take it for the 50th time, it doesn't feel good anymore, actually. And they still take it because it's now a habit and it's outcome independent. So it takes a lot of reinforcement, a lot of craving to make something a habit. And the faster it becomes a habit, the more craving it is eliciting. Okay. So what we then did was we asked, how long does it take for helping to become a habit? And we guessed that it was either 2 days or 4 days of opening. So we tested the rats, and after they helped for 2 days, we tested them with an empty restrainer, and every other rat went to 4 days and was tested with an empty restrainer. And here are the results. So this dotted line is where we switch from being tested with trapped rat to being tested with an empty restrainer. And after opening either twice or 4 times, didn't matter, they opened for the rest of eternity for an empty restrainer. So they're forming a habit very, very quickly. Now, just to put this in context, would they form as rapid a habit and as strong a habit with a good tasting food? So we tested them with chocolate, and here's the way that this would work. After opening twice for the chocolate chips in a strain, we put chocolate chips in the restrainer, then they'd be tested with empty. And what we and so here's an example of a rat. He opened twice in a row on days 1 and 2 for the chocolate chips. And then we tested him with empty, and he didn't open. So then at the end, again, we did a pilot. And for this guy, we tested him with a rat twice, and he opened twice. He already knows how to open because he did it for the chips. He opens twice, and after that, he opens for empty. So he forms a habit after opening for a rat, but not after opening this, doing the same exact action, opening a door for chocolate chips. So opening for a rat, helping, is more habit forming than highly palatable food. And the habit is stronger. So the very few of the rats, only half the rats met criteria. Only half of them opened twice in a row for chocolate, whereas 21 of 24 rats opened at least twice in a row for a rat. And the proportion of times that they opened for the empty restrainer was very close to 100 for the trapped rat, and much actually it was 100 for the trapped rat, and it was much lower. It was quite a bit lower for after opening for chocolate. So this is all to say that rats will pay to help. They'll pay in they'll actually that doesn't tell you that. So we did an experiment that told us that they will pay to help, and that's illustrated here. So we had rats that knew how to open the door, and we separated them. So the free rats over here, the trapped rats over here, and in between is a corridor. And in that corridor, we put vegetable oil. So it's a pool that fills the corridor, and it's filled with vegetable oil, and the rats would not go across it. But the minute that we switched the vegetable oil into water, they went screaming across it, which tells you that the cost that they're willing to pay is somewhere between walking through water and walking through oil. So they're willing to pay. Is everything okay there, Christine?
Yeah, it just says that there's 10 minutes left in the Zoom. But
okay.
If you need more time,
so what we can conclude from this is that helping feels good. I mean, it feels so good that, in fact, the person, the helper may experience, may believe that their actions have helped another person, have caused great, have helped the other person, when that may or may not be true. It's not necessarily, because they're blinded by that feeling, that warm feeling that they get from their own perception of having helped. It's a situation where the intention floods the actuality. And so, that's that is a problem, and particularly in medicine, where if helping feels so good, a helper may feel good when performing an action that, while intended to help, does not in fact help and may even harm. And so a physician may take an action to try and help a person, even if there's no evidence that action is actually helping them. You see this a lot with, for example, physicians not knowing what to do, so they prescribe antibiotics when there's no evidence that a person has a bacterial infection. They probably have a viral infection. So this is something to keep in mind, that it, there's a downside to helping feeling good. Okay, so that's what I have to tell you. I'm sorry I went over, but I'm happy to take any questions about either the work or University of Chicago. Yeah.
Suppose like the trapped rat and like the other like free one is like, what if the roles were switched? Do you think the time would like shorten, like to release them?
Yeah, we didn't do that, but a colleague in Japan, Nobuo Sato, did that. And when you switch, if a rat has been trapped, they will open faster and more. They'll just start doing it faster than if they've never experienced the trap.
This is more of a question about neuroscience research when you test with animals. I guess how acceptable or I guess how plausible are the claims that you can make about humans when the data is based off of rats and such? Because I know you mentioned like taking that data and applying it to human behavior and trying to understand it like in more of a human context. So is that widely, found in papers, that detail?
I mean, you have to make up your own mind, but a typical biologist will see the continuity of life, the continuity of evolved life, and the pathways that exist in the brain are not that, particularly the helping behavior is depending largely on subcortical pathways, and they're not that different in the rat and the human. Places where rats and humans are really, really different are things such as eye movements or the neocortex. But as far as subcortical pathways, they're not that different. So in general, most neurobiologists would think that other mammals are pretty good proxies for humans. Now, if you talk to at least some psychologists, sociologists, and anthropologists, they would subscribe to something that I would call human exceptionalism, that humans are a very particular species. They're not really sitting on the tree of life. They're sitting on a separate tree of life. And so for them, that's they're skeptical about that because they think humans are a very, very special animal. I mean, along with people in say divinity schools. But for most biologists, I would say that, yeah, there are going to be species differences, but the degree of difference that you see depends on the particular phenomenon that you're looking at. And for the phenomena such as helping, we don't have any evidence that there are enormous differences.
Thank you so much.
I have one more question about like if helping behavior is so addictive that rats will go to like very extreme lengths to help each other. How do you explain like how in human populations sometimes people can help but they don't, and they intentionally don't?
So what happens, I didn't show you the social bias of helping. So rats will only help rats of a type that they're familiar with. And Inbal recently, a year or two ago, established that what happens is that when the rats are very young, they'll help anybody and then when the rats get past, I think, 6 weeks of age, they stop helping certain individuals that are part of an out group that are unfamiliar. And that is exactly what you see in children. They switch at age 4. So what's being taught, or what's being learned, I'll say it that way, what's being learned is not that not to help, but who not to help. Why? Because helping is very resource depleting. It takes a lot of energy. It's something that you want to, if you helped everyone that you saw who was in need, you would have no money and you would never reach home. So you need to, it's biologically advantageous to make sure that it is preferentially offered to those with whom you have a relationship, a productive relationship. Yeah.
Anyone else? If not, I think we're a little out of time.
Okay, good.
Yeah, thank you so much for coming and
excellent
about your research. It's really great meeting you.
Thank you.
Okay, good. Bye, everyone.
So